Hello everyone. Today we present our project on an international student survival assistant using RAG. This project focuses on improving how students access reliable academic and visa related information. Our project is in the domain of international student support system. We focus on answering real world questions related to visa rules like F1, CPT, OPT, academic policies, registration and tuition. To solve this, we use a retrieval augmented generation system which combines document retrieval with LLM based answer generation. The main problem is that international students struggle to find clear and reliable answers. Information is scattered across multiple resources written in complex policy language. Existing chatbots often provide incorrect or incomplete answers or hallucinate policies. This can lead to confusion and serious academic or visa risk. Our goal is to build a RAG based system that provides accurate document grounded answers. We also compare three models Llama, Mistral, and Phi and analyze how they behave in policy heavy, ambiguous, real world scenarios. Our dataset include 10 official documents such as visa rules, CPT guidelines, OPT guidelines, and academic policies. These are collected from university resources. The dataset is domain specific, policy heavy, real world relevant. We evaluate the system using different types of questions factual questions, procedural questions, policy based questions, ambiguous questions. This helps us test how well models use retrieved context, handle ambiguity, and avoid hallucination. And the system architecture shows that how it follows a RAG pipeline. Documents are collected and split into chunks, converted into embeddings, stored in FAISs, and relevant chunks are retrieved from each query, then passed to the LLM to generate answers. And all models use the same retrieved context, ensuring fair comparison.
So moving on to the coding part, we have installed all the required libraries Llama, FAISS, Sentence Transformers and Olama, and we have imported them all. And here we used text loader to bring in our data, a file called text.data.txt that contains all our university rules, but AI models can't read a whole textbook at once. So we used recursive character text splitter. This breaks the text into 500 characters chunks so that AI can digest the information more easily. This is where the retrieval part RAG begins. We used a model called All-Mini LM to turn our text chunks into mathematical vectors, and we stored those coordinates in a FAISS vector database. We have created a retriever to k equal to 3, which means whenever a student asks a question, the system will instantly grab the three most relevant pieces of text from our handbook to help answer it. We initialized three different LLMs Llama 3, Mistral, and Phi. We wanted to see which one handles the student queries the best. And here is our core logic, the ask RAG function. Look at our prompt. We wrote here that we are giving the AI model a very strict rule to only use the provided context. If the answer isn't there, then say that you don't know. This prevents the AI model from hallucinating or making up false rules. And we put it into test with 10 real world questions about F1 visa and work permits. You can see the output below where all three models give their answers side by side here. And then we have saved our results into a CSV file called result.csv, and then from here it's all about evaluation, and we wrote some custom functions to score the model here. After crunching the numbers, we got uh, for a specific task, Phi 3 actually came out to be top, but Mistral is more balanced and reliable. We implemented the system using FAISS for vector search, Hugging Face, and Olama for LLMs, Python for the pipeline. The key steps including chunking documents, generating embeddings, retrieving context, passing to LLMs. The same pipeline is used for all the models. We evaluated the model using accuracy, groundedness, completeness, clarity, hallucination risk. And we have also checked whether the retrieved context is relevant and whether the model actually uses it. Moving on to the results, our result shows that our all models improve when using RAG. However, the performance differs across models. Even with the same context, the model behaves differently in accuracy, reasoning, and hallucination. Mistral performs better overall with higher accuracy. Phi shows strong reasoning but has higher hallucination risk. Llama is stable and reliable but less detailed. This shows a trade off between reasoning and reliability. We observed that RAG significantly improves answer quality, but model behavior still plays a major role. And also, ambiguous and policy based questions remain challenging. Better reasoning does not always means better reliability. Some limitations include small data set, manual evaluation basis, retrieval errors affecting answers. Future works including expanding dataset, improving retrieval, and adding hallucination detection. In conclusion, we built a RAG based student support system, compared multiple LLMs in a real world settings. The final takeaway is RAG improves reliability, but model choice still matter. Mistral was the most balanced and reliable model. Thank you for listening.